What's up guys, and in today's video we're going to be looking at how we can solve trigonometric equations, both starting with simple and then moving on to more advanced equations. So in order to do this, it does assume that you have understanding of the unit circle as well as what radians are, as all these questions will be written in terms of radians. But just for your help, I've written here the conversion between radians, which in this case is 2 pi, and the degrees, which is 360. So 2 pi radians is 360 degrees. Okay, so in this equation we've got cos of x equals 1/2. Now the first thing we want to do is find the related angle. That is, if I draw a set of axes, the angle we move from the x-axis on this side or on this side. So it could be that way, or that way. Now, if we use our exact value triangles, let's draw one up quickly. Pi 3, pi on 6. We see that for cos of x to equal 1/2, the angle has to be pi on 3. So therefore, our related angle equals pi on 3. Now the next thing to do is look at the right hand side of the equation, so what cos of the angle equals, and we want to see, is it positive or negative? Now in this case it's positive 1/2, so that means cos x is positive. Now if we remember our unit circle, all stations to central, we can see that cos is positive in the 4th quadrant as well as the 1st quadrant. So that means we have to move from this x-axis in this direction by the related angle, but we also have to move in this direction as well by the related angle. So if we do that, we start from 0 degrees and we move pi on 3. That means a solution of x is pi on 3, and we're going from a full rotation, so 2 pi, and then we're minusing pi on 3. So 2 pi minus pi on 3, which means that x equals pi on 3 and 5 pi on 3. See, in the at the start of the equation we define the domain as being 0 is less than or equal to x, which is less than or equal to 2 pi. So therefore these are the only two solutions. Alright, we'll explore this further with another example, this time a little bit more complicated, and it's going to have the same domain. So in this case we have cos squared x equals 3/4. Now the first thing we want to do is remove the square in the cos function. So by doing that we get cos x equals root 3 on 2. Note that root 4 is just 2. And remember, it has to be plus or minus. Now the first thing we want to do is find the related angle. So for what angle is cos equal to root 3 on 2? So if we draw out our exact value triangle, we see that it's pi on 6, adjacent of the hypotenuse. So therefore, theta related equals pi on 6. That's the degree we're going to be moving from the x-axis. Now notice how, because we square rooted it, it can be plus or minus. So that means we have a solution in every single quadrant. So we can go that way, pi on 6, this way, pi on 6, that way, pi on 6, and this way, pi on 6. Also, it's important to know that the related angle is just the acute angle, which is what allows us to do this. So, therefore, our solutions are going to be, if we start at 0 and we move pi on 6, x is going to be pi on 6, and we're going from 180 degrees around, and we're moving back pi on 6. So 180 degrees is pi, so it's pi minus pi on 6. And then from the same position, we're moving forward pi on 6, so it's pi plus pi on 6. And then for the final one, we're moving from a fourth rotation back into the fourth quadrant, so it's 2 pi minus pi on 6. And if we simplify each of these equations, or each of these values, we get pi on 6, 5 pi on 6, 7 pi on 6, and 11 pi on 6, and they are your 4 equations. And now to finish off, we're going to be looking at a bit of a complicated equation, but nonetheless, it's very doable. The domain's going to be the same, 2 pi. So the first thing I want to do is make a substitution. Now we can see that cos is being squared, or cos of x is squared here, and it's on its own here. So this is reducible to a quadratic equation. So I'm going to make a substitution. Let u equal cos of x. Now, you don't have to make the substitution, but I think you can factorize it as cos, but I think it's easier to see when you make a substitution. So therefore 2u squared plus u minus 1 equals 0. And factorizing this, we get 2u, let's think about this. It's going to be plus 1 minus 1, and therefore 2u minus 1 can equal 0, or u plus 1 equals 0. And if we solve each of these, we get u equals a half and u equals minus 1. So now that we know the values of u, we can solve the values of x. So that means that cos of x, because u is cos of x can equal a half, or cos of x equals -1. So I'm going to start with this one over here. Cos of x equals -1. If we think about it, using our unit circle, cos of x represents the x coordinate on the unit circle. So if the circle is 1 unit in each direction, there's only going to be one place where the x coordinate is equal to -1, and that's here. As you can see, it's moved -1 from the origin to the circle. So that value from all the way around to there is pi radians. And therefore x can equal pi. Now let's look at the other equation. First thing you want to do is find the related angle of this equation. So theta related equals, if we draw out our unit circle again, no, sorry, the exact value triangle, we see that for cos of x to equal 1/2, the related angle is pi on 3, so the acute angle. Now if we look back, we can see that cos of x is positive, so that means that it's only gonna have solutions in the first quadrant and the fourth quadrant. So if we think about the first quadrant, it's moving from 0 and it's moving by the related angle pi on 3. So therefore x can be pi on 3. And for this solution in the fourth quadrant, you're moving from a full rotation back the related angle pi on 3. So it's 2 pi minus pi on 3. So x equals pi on 3, 5 pi on 3, and also the solution from up here where x is pi. And that concludes this video, and I hope it helps. Bye.